Been talking about how we can add vectors by drawing triangles, by drawing polygons geometrically. Let's get to know more about the resultant that you get by adding two vectors. So if you had, let's suppose, two vectors a and b, vector a and vector b, and you shifted them so that they just coincide, their tails coincide. And in that case, if this is vector b, you want to figure out what is the sum of these two vectors. So let's make some background info. Let's give you some background info for this entire video. This vector a will be having magnitude a, capital A. This vector b will have magnitude capital B. The angle that they make between their tails, that's going to be theta. And the resultant that you would get will be r vector, and its magnitude will be r. So just for information. Now, if you want to find out the resultant of these vectors, the first thing that you need to do is align either the head of A with the tail of B, or the tail of B with the head of A. So let's do that. So let's parallelly take this vector B and shift it here. So something like this. Or let's make it even better. So this is something that's called parallel translation, and it doesn't really affect the vector. The two vectors that you see here and the one that the two vectors here and here are just equal, since you just draw the same vector with the same magnitude and the same direction, just they have different starting points. Once you have done that, once you have sort of made this basic template, now you can add these vectors. So the resultant that you would get would look something like this. It will look something like this. And this vector, we already know it. We named it as r, and its magnitude is going to be r, capital R as well. And you want to figure out more about this vector. You want to figure out what angle does it make with the other vectors, what is the magnitude capital R. So let's do that. So first of all, let's translate this vector problem into an easier triangle problem. So what we can do is we can just take this triangle that you have right here. So you start out with a blue line, and you're just forgetting the orientations these vectors have for a minute. So you start out with a vector A, and for that you write a side length A. With that side length A, you draw a side length B. Since this is B, then this must also be B. And you draw that side length B. And what angle do these two make? Well, these two make an angle of 180 degrees minus theta. Why? Because these two lines are parallel, and the sum of angles, the corresponding interior angles that you say is going to be 180 degrees. They are supplementary. So with an angle of 180 degrees minus theta, you draw another line, B, and the angle between them is 180 degrees minus theta, and you join these. So you join these, and this line has length r. Once you have joined these lines, you now want to figure out the length of r, and there are many ways you can do that. Now I'll choose the easiest way to do this. So the easiest way to figure out lengths is using a right angle triangle, since you can then use the Pythagoras' theorem, but there are no right angles here. So one thing you can do is extend this side A so that you get a right angle. So you extend this side A in such a way that you get sort of a right angle. So something like this. And once you have done that, once you have figured out a way to do that, this is a right angle, by the way, you now can, if you figure out the side length of this side right here and the side length of this entire side right there, you can figure out what r is. So now we have translated a vector problem into a triangle problem. Let's convert this triangle problem into a smaller triangle problem. So you take this side, the smaller right angle triangle that you make. So the right side B, and you combine this with the two red legs of the right angle triangle that you've got, and this is a right angle triangle. Now you just know the side. You need to know one other angle to apply the trigonometry required here. So since this is a straight line, the sum of angles, this one and this angle, is going to be 180 degrees. One of this is 180 degrees minus theta, so this must be theta. So this is the angle theta. Now you can figure out what these legs are. You can figure out what this side is. So if this side is x, then x over b is equal to sine of theta. And that means that x equals b multiplied by the sine of theta. Similarly, if this is y, then y over b is equal to the cosine of theta. And that means y is equal to b times the cosine of theta. Now you can just use this fact. You can put it right here. So this side right here is b cosine theta, and this side here is b sine theta. Now what you can do is you can just forget that there were some sides here. Just erase all of them, and now you are left with this right angle triangle whose two sides are, first is b sine theta, and the second one is a plus b cos theta. And you can now solve for r here. So now r squared, by Pythagoras' theorem, the hypotenuse squared is equal to a plus b cosine theta, all this squared, since this is just one entire side, plus this side right here, this is b sine theta, so b times sine of theta squared. You can expand this term, so this will be equal to a squared plus b squared times the cosine squared plus 2 times a times b cos theta. Let me do that in a different color. A times b cos theta. Plus, you also need to consider this part, so b squared sine squared theta. Now, if you look carefully, then b squared cos squared theta plus b squared sine squared theta, they both add up to give b squared, since you get b squared in common, and cos squared theta plus sine squared theta remain. This quantity is just 1, so you just are left with b squared. So now you arrive at r squared. The magnitude of the resultant of adding two vectors a and b is equal to the first vector's magnitude squared plus b squared plus 2ab cosine of theta. And now you can take the square root of both sides. So to summarize, if you had these two vectors a and b, then the resultant that you get, you can find out its magnitude, and the magnitude is, just for one more time, the magnitude is equal to the square root of a squared plus b squared plus 2ab plus 2ab cosine of theta. Notice this is the same theta that we started working with right here. That was in the problem statement. So given two vectors that are aligned so that the angle that that they make when you align their tails is theta, then you can find out the magnitude of the resultant vector. And this idea by drawing parallelograms sometimes is referred to as the parallelogram law. If you want to name it as that, no issues. If you don't want to name it as the parallelogram, still no issues. You still have a nice and a formula. One other thing we can do, we can tweak a few things. We can also figure out what is the angle that this vector r makes with a. Since you know that vector b makes an angle theta with a, what is the angle that vector r makes with a? So sort of you're fixing a to be sort of the coordinate axis, not the coordinate axis, but the sort of standard, and you're measuring angles with respect to it. So if this angle here is said to be, let's say, beta, then this angle beta and the angle that this side has, they're both the same thing. This is also going to be beta. And since this is a right angle triangle, you can still use trigonometry. So you have sine of beta is equal to this b sine theta over, I might skip on the edges a bit, but b sine theta over a plus b cos theta. And there you have it. Given two vectors a and b, which make an angle theta between them, you can figure out the magnitude and the direction of the resultant vector that you get by adding them. And if you want to do a quick example, you can do that. So let's do it. So if you had vector A, which is 5 meters in length, or let's just take units. Let's not take any dimensions. So let's just take 5 units, and another vector B which has magnitude 6 units, and they make an angle, let's say 60 degrees. So 60 degrees angle between them. What can we say about the resultant that you get by adding them? So R is equal to the square root of a squared. So 5 squared plus b squared. So 6 squared plus 2ab, so 5 times 6, times the cosine of 60. The cosine of 60 degrees is a half, so you can just do that right away. And if you solve for that, so 2 cancels 2, you get the square root, of 25 plus 36 plus 30, that's equal to the square root of 66 plus 25, and that's equal to the square root of 91. And let's notice a few things. So you could also figure out the direction that it makes. So let's anyway do that. So sine of beta, the angle beta that the resultant makes with the vector A, that's equal to b sine theta over a plus b cos theta. So b sine theta is 6 times sine of theta is sine of 60 degrees, that's square root 3 over 2, over a plus b cos theta, so 5 plus b cos theta, so 6 times half. This is equal to 3 root 3, we just cancel them out by the way, 3 root 3 over 8, and you can just do a arc sine or sine inverse of that and you'll get the answer. A few things to notice. First, you can remember this formula. Sort of, just to keep it handy in use, by remembering the fact that the a plus b squared is equal to a squared plus b squared plus 2ab. Sort of, this is the same formula, except you have this theta term that you need to consider, and just remember that you need to put in a theta. Oops, sorry, just erase some of that. But just remember that you just write out a plus b squared, a plus b whole squared, and you plug in a cos theta with it. You won't be needing this direction part as much as you would need the magnitude part, but it still is a nice to have. A few more things you can notice. The minimum resultant you would get, if you fix a and b, if you fix the magnitudes, so a squared plus b squared plus 2ab cosine of theta, you can't really change a, b, and b. The only thing you can change is theta itself. So the minimum value that cos of theta can get is -1, and the maximum value it can get is +1. But if you're talking about the minimum resultant, that comes when cos of theta is -1, and that happens when you have pi to be equal to theta, or pi and 3 pi, or multiples like that. But You can verify that using just common sense as well, since now you have a vector A, let's say 5 units, and a vector B, let's say 2 units. And the minimum resultant you would get is only when they are both sort of standing away as far as away they can be from each other, and then they give you 3. 5 minus 2 is a 3. The maximum resultant will happen when when cos of theta is 0, is 1, is when cos of theta gets its maximum value, and cos of theta's maximum value is equal to 1. And in that case, you just add those two vectors. So now, if you just focus on the situation that we had previously, you can just now flip this vector to the other side, and you now have 2 here. So now you have 5 plus 2, now we would have a 7. So when you have the minimum resultant, you have a squared plus b squared minus 2ab, the square root of that, that's your resultant, and that's equal to a minus b. And if you have, or you could also have, since you're dealing with the magnitude, then you can either have a minus b or b minus a. But in any case, just remember that since the magnitude has to be a positive number, you need to just put in a modulus sign right there as well. And in the maximum case, in the maximum resultant case, you would have a squared plus b squared plus 2ab, all that under the square root, and that will be a plus b. A plus b. You don't need to put in the modulus sign here right now, since a and b are already positive integers. They will add up and give you another positive integer. So hopefully you now understand how you can define the magnitude and direction of the resultant that you get when you add two vectors that make certain angle between them. See you in the next video.